Let's start with an overview of the fundamentals of databases and the SQL language. Even if you're familiar with other programming languages like Java, Ruby, or one of the variants of C, databases work in a slightly different manner, and bringing Java thinking into SQL programming is going to result in poorly performing queries that run forever. So with that out of the way, let's take a high-level look at database fundamentals. So first off, let's understand what a database is. A database is a collection of information that's organized to be easily accessed, managed, and updated. It manages and directs workloads that produce and consume data, and it optimizes performance of data retrieval. Finally, a database secures information to enable reading and writing data by authorized users. In other words, a database is a complete package for reading, writing, organizing, managing, and securing data. A database consists of one or more tables. Tables organize data into a two-dimensional matrix of rows and columns. Rows are sometimes called records. A row usually represents an item, whether it's a person, a financial transaction, an event, or so on. Rows are frequently added, modified, or deleted from a table. Columns are also known as fields. A column serves as a descriptive property of the item in the row. Columns are defined when the table is defined, and they rarely change. They also have a defined data type, whether it's a numeric, text, date-time data type, and so on. Each column in a table has a defined data type. For every row in that column, the data type is the same. There are many different data types available, but they generally fall into a few broad categories: numeric, text, date-time, and then you have some special types, such as binary data, globally unique identifiers or GUIDs, geospatial data, and so on. Most of the time, you probably won't be dealing with special types of data. Most of the time, you'll be dealing with numeric, text, or date-time data types. So let's look at an example. Here's a table containing the first 12 presidents of the United States of America. There's a president ID column, which contains a numerical value that identifies the row in code. It also identifies the order in which the president was elected, but that's a side benefit. The first name and last name are two separate columns with character data each. Character data is also known as string data. This is often done in case you want to sort a query by last name, or in some cases, you may want to display a name showing the last name first, separated by a comma. The date of birth and the date of death are date columns. And finally, home state shows the home state each president was elected from, using the standard two-digit abbreviation for each state. Each column is strongly typed. For example, in the President ID column, I cannot put the word first under President ID for George Washington. I can only put the number 1. Also, my home state column is also strictly defined to allow only strings of exactly 2 text character length. Some of my other ones, like the first name and last name, they can allow variable length strings. This is something that you would define as you define the data type for the string itself. As new presidents are elected, I can add rows to this table with a minimum amount of fuss. I can also change or delete rows pretty easily if I make a mistake entering information. However, my columns are fixed, both in their definition as well as the order in the table. Adding, changing, or removing a column requires a major table change and is more liable to cause errors in code. So you really shouldn't be changing columns unless you absolutely have to. So let's talk a little bit about relational databases. A relational database is a database that allows you to compare the data from one table to another. Each row in a table has a uniquely identifying value or key, which allows it to join the contents of one row in a table to one or more rows in another table. what makes a relational database so valuable is that it allows you to combine values from different tables together in a query. It also protects against bad data by enforcing referential data integrity. So going back to our example before on presidents, so I've added a second table, and this is a table of states in the United States of America. So you can see that my state code, state name, and date of admission. This is a partial list, of course, just for demonstration purposes only. So in my relational database, I joined the home state column of my president's table to the state code of the state column. And I would do this for a couple of reasons. One, if I'm writing a report or writing a query where I need to show the full state name rather than just the state code, then I do the join to make that. Also, if I wanted to write a special query, for example, I want to show all the presidents from states that have been admitted to the Union after 1800. So I would do that join to get my president, so I would get my information from the president column table, but then I would join it to my states column in order to filter by the date of admission. Let's talk for a minute about primary keys. A primary key is a column or set of columns which uniquely identify a row in the table. For any given value or combination of values in the primary key, there can be only one row with that value. You cannot have two or more rows with the same value in the primary key column. If you have a primary key with two or more columns, a value can be repeated in one column, provided that the combination of values in the other columns are not duplicated. The combination of values in all columns must be unique. Primary keys consisting of two or more columns are sometimes known as composite keys. So if we go back to our example before, you can see that I've highlighted the president ID column. As I said before, I'm using this as a way to uniquely identify the row within the table. So president ID is my primary key for my president's table. So I cannot have two or more rows with the same number. So I cannot have two number ones in my president's table because president ID is my primary key. Now I can't say the same thing about, it's like if I was to do a combination of first name and last name. It's always possible in the future that you could have a president that would have the same first name and the same last name as an existing president. Rare, but it's possible. But usually this kind of occurs more often if you're doing a standard customer or a customer type of table, for example, where you have millions. And it's like the chances of having a same first name and last name for two different people are much higher. So one of the key concepts when it comes to primary keys is the idea of a foreign key. So a foreign key is a column or a group of columns in a table that references a primary key in another table. All of the values in the foreign key must also exist in the referenced primary key. You cannot have a value in a foreign key column set that doesn't exist in the primary key of the other table being referenced. So if I go back to my relational example before, so as you saw before, it's like I have a home state in my president's table, which is the 2-digit code that I can use to join to the state code in my states table. So home state really is a foreign key of the states code because this means that you can have a correct join. If I had an incorrect join in my home state column, for example, I put like XX as a home state. Well, there is no XX in my state codes. So a foreign key prevents that entry from making it into the database, whether it's adding a new record or updating an existing record. So I cannot have an invalid state code. So it's like my home state has to be one of the 50 states that appears in the state code. So when it comes to databases, database design generally falls into two broad categories, OLTP and OLAP. The latter is sometimes pronounced as OLAP. So OLTP stands for Online Transaction Processing. OLTP databases generally support applications and are optimized to handle many small read and write operations running simultaneously. This is the typical category used for enterprise systems and web applications. On the other hand, OLAP stands for OLAP, Online Analytical Processing. OLAP or OLAP databases support business intelligence processes backed by massive data warehouses. The number of users is fewer in an OLAP database, but the amount of data being loaded, processed, or analyzed at any given time is much larger in scale. So here's a compare and contrast between OLTP and OLAP. So in my OLTP, the purpose is to control and run fundamental business tasks. My source of data is usually operational data that's generated by front-end applications. So if you're dealing with like a web page or a mobile app or even a desktop application, these things are kind of generating data from the user interactions, from values that are being added or changed, and then you kind of flows through the application into the database. So that's where the source of the data is typically coming from with an OLTP. The queries in an OLTP are relatively standardized and they're very simple. For example, it's like if you are running an OLTP supporting a web application, like for like a online payment system or something, you're going to be most of the time you're going to be generating the same type of queries. Like you're going to get like all the financial transactions in the last month, or you're going to be writing like a customer's order information and so forth. So it's like they're pretty standard. The rows read per the query for an OLTP are relatively small, and the row writes are also small, but you're going to have a lot of them running simultaneously. In order to meet an OLTP, you have to have a highly normalized design with many tables. So when I talk about normalization, we'll talk about normalization later. And the main performance challenge when working with an OLTP is that you're reading and you're writing multiple connections simultaneously. So that's kind of like where you need to be very efficient in your queries, because it's like you need to make sure it's like everything kind of, you have a small query, but it needs to run, but you have a lot of them going on all at once. Now contrast that a little bit with OLAP. So the purpose of an OLAP database is to help with planning, problem solving, and decision support. So OLAP is a lot different than OLTP because OLTP is running the application, but OLAP is taking that data, it's actually feeding into another one where you have business leaders and analysts that are looking at that data and trying to figure out, okay, what's the best course of action for the business. So your source of data for an OLAP is typically other databases, usually your OLTP database. Again, OLTP is not optimized for analysis. So often what will happen is you'll take the data from an OLTP, you'll run it through a process to transform it to something to an OLAP model, and then you'll feed that into another database. With an OLAP database, your queries are often pretty complex and they often involve aggregation. So aggregations are things such as sums, averages, counts, and so forth. Basically, you take your input is going to take a lot of rows, but your output is going to be a single value. As such, the rows read per your query are going to be relatively large. Now, in an OLAP database, your row writes usually come from one large process called an ETL process. ETL stands for extract, transform, and load. This is a lot different than an OLTP. It's like if you look to the left, it says many small transactions running simultaneously. On the other hand, with an OLAP, you've got one transaction, but it's writing a large amount of data. So your overall volume may be the same, but rather than coming from multiple sources, it's coming from one source. Now, in order to handle all the special challenges with an OLTP database, you'll have a typically denormalized design with fewer tables, but you have a little bit more redundancy in the data columns. And the big performance challenge with an OLAP is having a quick response time for very complex queries. So we touched upon normalization and denormalization before. So normalization is the process of reducing redundancy of the data. It is very effective in reducing the storage requirements of the data. However, an extreme amount of normalization hampers the performance of queries because they must include many tables together in complex joins. Sometimes a little redundancy in a table can result in vastly improved query performance and speed. When a table includes redundant data for improved performance, they are considered denormalized. So let's look at our example before. So this is an example of normalization because I've got all my precedence data in one table and all my states in another. So I'm using joins in order to, if I needed to match data from my states table with data from my precedence table. So this is an example of a normalized design. Now here's an example of a denormalized design. So what I've done here is I've taken my query from before and I've kind of copied all my columns from the states table into my precedence table. So you can see it's like with my home state, it is in addition to the home state column that I had before, now I also have my state name and my date of admission in my precedence table. And you can see it's like there's a little bit of duplication going on in the state name. So you've got 1, 2, 3, 4, 5 examples of Virginia and 2 examples of Tennessee for state names going on. And then of course the date of admission also gets duplicated appropriately. Now you can see it's like you can see where this can be a problem when it comes to data integrity, because you can have like slight misspellings of the state names, or maybe a date of admission for George Washington for Virginia might be different than the one for Thomas Jefferson because of a typo or an error. So this is kind of like the risk that you have with a denormalized table. On the other hand, because you have eliminated this join, if you were to write a query against this, you would actually get a little bit of improved performance. You won't see that as much with a small table like this, but you will see a performance difference when you're dealing with very large tables in the millions. Let's talk for a minute about database concurrency. Database concurrency ensures that the data is read or written in a consistent manner. This ensures that results that users retrieve in a query are correct and accurate. What makes concurrency tricky is the fact that at any given time, multiple users can be reading or writing data to the database at the same time. If you don't have a concurrency system, you are liable to run into a lot of problems with the data quality. Specifically, you can deal with lost updates, dirty reads, non-repeatable reads, and phantom records. And one thing I should point out too is like all these problems that you have in concurrency, these actually occur under. So these are not user errors that are causing concurrency problems. These are problems that can occur underneath the system if you don't have it in place. Now, fortunately for a database does ensure that you will have these does have these controls in place to make sure that you don't have these concurrency problems. So let's talk for a minute about ACID. ACID is an acronym that defines the consistency of data in a relational database. Since data is constantly being read and written by multiple processes at once, there has to be a system in place to guarantee that the data being read is reliable and true. So ACID is the acronym that is used, and it consists of 4 parts: atomicity, consistency, isolation, and durability. Atomicity means that every task in an operation succeeds or fails together. In other words, your write operation is all or nothing. Consistency means that when the transaction completes, the database is structurally sound. So adding, changing, or deleting data doesn't compromise the integrity of the table or the database. Isolation means that each transaction is independent unto itself. No transaction has access to another one that is in an unfinished state. And finally, with durability, the results of applying a transaction are permanent, even in the presence of failures. Once the transaction is complete, it will persist as complete and cannot be undone. So when working with relational databases, the primary programming language used is SQL. SQL, or SQL, stands for Structured Query Language. It is the language used for retrieving and writing data, as well as building the structures that organize databases and the security for managing data access security. SQL is the core language for all relational database systems. However, different database systems do have their own variants of SQL. So what I'll be covering in this lesson is the Microsoft SQL Server system produced by Microsoft. So this is their variant of SQL, of SQL, is called Transact SQL. So within SQL, there are different commands. However, they fall into 5 broad categories. The first one are queries. Queries return data sets arranged in columns and rows. This happens through the select command. The second one is data manipulation language, or DML. DML writes data to tables. The 3 DML components are insert, update, and delete. Now, if you work with some other instructors, they may kind of lump queries and DML together as DML. Some places will include select as a DML command along with insert, update, and delete. This kind of falls into a broader programming concept called CRUD, which is create, read, update, and delete. I kind of break this out just because it's like when you most of the time you're going to be dealing with queries, and and a lot of your effort is in there. So I really kind of break that. So even though it may be technically wrong to break queries out, I do just because it makes it a lot simpler for a newcomer to understand. The third type of command is data definition language, or DDL. DDL defines and builds the structures that store and manage data, including databases and tables. So your 3 main DDL commands are create, alter, and drop. You can make an analogy between create, alter, and drop with insert, update, and delete, except that create, alter, drop, except that DDL deals with structures, whereas DML deals with data. The fourth type of command is a data security language. Now, data security language grants who has access to which data and what they are allowed to do with it. The 3 main DSL commands are grant, revoke, and deny. And finally, the last type of SQL command is a data transaction language. So we talked about concurrency before. So data transaction language manages the queries. So most of the time this is done automatically, but in some cases you may need to have more granular control over the transaction that writes data to the database. I won't cover the commands here because they can vary a lot from system to system, but you just need to be aware that that language that kind of governs the transaction itself is a special category that exists. Now, before we conclude this lesson, I want to go a little bit into non-relational databases, since this is a very popular topic that seems to come up a lot. Besides relational databases, there are other types of databases which are considered non-relational. These are generally lumped together into a category called NoSQL databases. Originally, non-relational databases did not adopt the SQL standard, but as they have matured in usage, they have incorporated many aspects of the SQL language. So today, NoSQL has been retroactively defined to mean not only SQL. Now, when you're dealing with non-relational databases, you may sometimes hear about a concept of base when it comes to non-relational databases. Base is an alternative consistency model that is different from ACID. It commonly occurs in as I mentioned before, it commonly occurs in alternate database designs like NoSQL. So with base, it's a little bit different because base stands for three concepts. So the first two is basic availability, which means that the database appears to work most of the time, rather than kind of like with ACID, which guarantees that your database operation succeeds all the time. A base is considered a soft state database, which means soft state conservancy, which means stores don't have to be write consistent, nor do different replicas have to be mutually consistent all the time. And then with base is like the final part of base is eventual consistency, which means that your storage exhibit consistency at some later point. In other words, there's a lazy read. This typically occurs as like and base is very useful. It's like if you were writing something like a non-essential, like a user interface or a data cache, because it's a lot easier because the operation is a lot faster and you're not hung up. You would not use base with something where you're dealing with highly regulated or very critical data. For example, a financial transaction. You really don't want to be using base concurrency in that case. You really want to stick with ACID. Now, base is not a feature of most relational SQL databases. However, it is a common concept in programming that you should be aware. Also, some kinds of applications lend themselves better to a base approach, so you should be prepared to code in a way that emulates base principles if you are working with a predominantly ACID database. So when it comes to NoSQL databases, they generally fall into one of four categories: key value, wide column, document, and graph. So let's go through these quickly. So with a key value database, it consists of, your database is really a single table with two columns. A key identifier column, which is usually some sort of GUID or some sort of a binary, paired with a value column. Now these are very useful for caching data into memory for fast performance. Your typical examples of a key value database include systems such as Redis and Memcache. The next type of NoSQL database is a wide column. So a wide column consists of a single table with a lot of columns that are created as they are needed. So a wide column is similar to a key value, except that with a wide column you can, except with a key value, you only have two columns, whereas with the wide columns you can have a lot of columns. Now the thing is, when you're dealing with a wide column database, you're going to have a lot more columns than normally found in relational databases, and you can be storing multiple entities. So for example, if you look at my example before where I had presidents and I have states, it's going to be, now one approach you can do is you can do it interleave, you can have that denormalized design, which I showed you before, or you can kind of do some interleaving. And usually this is kind of like you can have interleaving where you'll have like different types, where you can have like different entity types. So it's like if I had an exhibit, for example, I could have my president's data, I could have my congressman data, I could have congressional data, I can have my Supreme Court data, my state governor's data, state legislature's data, and so forth. And then it just kind of anything that doesn't apply is like, I'll just leave those columns blank. But it's like, it does kind of create a lot more columns. So it's a lot simpler what the benefit for this is that it is a schema-less design, which means that you really don't have to build a data model in advance. In other words, you don't have to kind of define all the tables in advance. You just have one table and you just kind of add columns as you need it. So common examples of wide column databases are Cassandra and Essbase. Now, the third type of a NoSQL database is something called a document database. Now, document database stores data in a hierarchical format that allows you to store more complex data types, such as XML or JSON. A document database is commonly used in apps because it's like in a lot of applications, especially when you're dealing with mobile apps and web applications, your data is already going to be stored in that document format, in that JSON or that XML format. So it's like you just take the JSON that's being generated by your application and you just dump it into your document databases. Document databases are often, a lot of startups will often begin with a document database, because what's happening is with a startup, it's like their application, their business model is evolving very rapidly. So the data model also has to evolve very rapidly as well. And in order to do that, sometimes it's what they'll do. What it's easier to do is you just store the data in its raw document format, in its raw JSON or raw XML, and then kind of like as the business model stabilizes, then you can convert your JSON model into a more defined relational schema for better performance. So when it comes to document databases, your common examples include Mongo, Firestorm, and DynamoDB. The last type of database is a little bit different than the others. It's a graph database. And graph databases map the relationships between entities. So it is kind of, in some ways, it is a relational database, but it's a different type of relation, because it's like, rather than kind of like defining the tables, rather than kind of like having a relationship, it actually stores the relationship. So you have two types of tables in a graph database. You have nodes, which represent your entities. For example, so I could have a president's node, I could have a state's node, and then I can have edges, which represents an relationship. So as you recall before, I had my home state joined to the state code in my example. So that home state code relationship actually is stored as a separate table. So the benefit to using a graph database is to analyze second order and third order relationships. So it's like if you've been on like a social media platform like Amazon, where they kind of recommend friends or followers, they're using a graph database in order to kind of generate that relationship, because they're saying is like, hey, people that you friended have also friended these, and then they kind of tabulate, okay, this friend of a friend has the most common friends with you, common friends that you have as well. So that's how they kind of come up with this. So the best known example of a graph database is Neo4j. Now there are some other examples, but Neo4j is the best known out there. So these are the four types of NoSQLs that you will follow. And then there's a fifth, which is kind of like a hybrid, which is really a combination of all four. A lot of these alternative database systems are kind of moving towards a hybrid model. So you will see some aspects of like document databases within Cassandra, for example. So this is a high overview of databases and the SQL language. These concepts are applicable for any relational database system, whether it's Microsoft SQL Server, Oracle, MySQL, Postgres, and so forth. So in the next series of videos, I'll kind of walk you through how to set up a database on your own computer so you can begin practicing. And then we'll kind of start diving with the most fundamental of SQL statements, the select query. So I'll see you in the next lessons.
Welcome to this live screencast lesson where I will be walking you through how to install SQL Server Developer Edition on your computer. So SQL Server Developer Edition is a free version of Microsoft SQL Server, which you can download from the Microsoft website and install on your computer. So it will give you an opportunity to get some hands-on practice on some of the lessons that I will be covering as part of this course. So I've already gone ahead and downloaded the installation file from Microsoft. So you can see it is on my C temp folder. So I am just going to go ahead and let's open this up. And if you are running this on Windows, it will ask you if you want to make changes to your device. So the answer is yes. Okay, so it is opening and getting ready. So what we will do is we will select the basic installation. So this will install the basic features that you will need. We are actually going to be doing a little bit more after that, but I will walk you through this. So let's click on basic, and it will give you the terms and conditions of the license that you are working on, which is basically to say that you are using this for your own development purposes and you're not using this to run a business or anything like that. So I will go ahead and accept. So we will specify our install location. So by default, if you have Windows, it will install to your program files. And you can see here the requirements. So the minimum free space that is required is 9 gigabytes, and the size of the download is about 1.5 gigabytes. So let's go ahead and click install. So it is downloading the install package. Will be running, is running through the installation. So this is going to take a little bit of time. So while we are waiting for the installation, let me go ahead and show you where you can download the installation from. So I'm going to open up my web browser, in this case Microsoft Edge. So I will just type in to the search bar SQL Server Developer Edition, and it will bring up Microsoft screens where you can results or search results. So where you do is you click on the Microsoft.com and you look at the search results. It should say something to the effect of SQL Server downloads. So I'm going to open this in a new tab. And you can see where, and this will bring up the screen where you will be able to click the download link. So while the reason I came back here is I wanted to go through the requirements on your computer that you will need in order to run SQL Server effectively. So searching through, I will click on hardware and software requirements. So this will bring up a Microsoft documentation page on this hardware and software requirements. So I'm just gonna skim through this. You can search this for yourself and read this. So there are a number of things that are required. So the hard disk, you are requiring a minimum of 6 gigabytes of available hard disk space. You will need more, especially as you download, install, and set up your databases. So you will need a lot more space than just 6 gigabytes, but 6 is the minimum you need to actually run SQL Server. DVD drive, Super VGA monitor, connection to the internet. So here's the important part on memory. So the minimum memory requirements is 1 gigabyte, but what they recommend is that you should have at least 4 gigabytes. And I would actually recommend that you have much more than this. The other thing, okay, and then as far as your processor, what they're recommending is as a minimum a 64-bit processor at 1.4 gigahertz, but it's recommended at 2.0 gigahertz or faster. And again, the more memory you have, the more memory you can get a hold of, the more processor you can get a hold of, the better SQL Server is going to run on your computer. So let's go back and check on this. So it's still in the midst of the installation. So you can see it has downloaded all the necessary files from the internet, and now it is in process of installing them. So it looks like we're pretty close to done. It could be just a few more minutes while we are waiting for the installation to set up. So just hang tight for a little bit. One thing I really want to emphasize is all these lessons that I am going through with you will give you the necessary knowledge, but in order to develop skill at this, you really need to spend time practicing on the lessons that that will be as part of the course. One of the things you can do is you can download some sample databases. Microsoft has one which is called the AdventureWorks database. So you can download that, install that on SQL Server once you have that up and running, and that will give you a place where you can practice working on your coding skills, practice setting up queries, practice building tables and stored procedures. So we are almost done. Sometimes it's the last few bits that kind of takes the longest. And it has completed successfully. So it will give you some information about the setup. So the instance name, as we go through on the SQL Server overview, that is the name of this particular instance. So you can have more than one instance of SQL Server running on a computer, though I do not recommend it. The administrators, so by default, it will set you up as an administrator of SQL Server. Features install the SQL engine. Connection string is what you use if you are doing any programming in .NET. This is something that you need to pass into the .NET ADO connector in order to connect to the server. A number of log, media, and resource folders. So we are going to do, so at this point you can start running SQL Server, but we are going to do a few more installations. So I'm going to click on Customize. And this will bring up a window where we can add on some additional features. So again, we're waiting. It is doing a validation. It is doing a check. So it passed all the checks. So down here, the last one, the Windows Firewall, is just a warning that says that you make sure that, because the firewall is enabled, to make sure that you have the appropriate ports open. So we won't worry too much about that. Let's click on Next. So we are actually going to add features to an existing instance of SQL Server. So we will see that the instance we have just installed should come up, which is MS SQL Server. So let's click on Next. Okay, so these are the list of available features. So you have SQL Server replication, you have machine learning services, full text, data quality services, polybase analysis. You have support for the R and the Python language, but the two services that we will install, because we will cover these as part of the lesson, is integration services and also SQL Server replication. So we will install these additional services. We won't worry about the rest. So let's click on Next. And it'll give you a wait screen. These are service accounts. SQL Server runs on a number of different service accounts behind the scenes. So every time we add a new service, some of these new services will require their own service accounts that will be installed on your machine. And it will here's a summary of what we are going to install. So let's click on Install. And now we wait while it runs through our installation. Sometimes the waiting is the hardest part, and you don't really know. Sometimes you don't know for sure just how long it's going to take, because sometimes it zooms right through the progress bar, and then it gets to a certain point and it sticks and waits and waits and waits. So what I'm going to do, I'm going to go ahead and pause this broadcast while the installation is progressing, and once it's done, I will unpause it and we will resume. And we're back. It is finishing up the installation. So you can see the results of our installation. Our 2 extra services were successful in installing onto our computer. So let's go ahead and close this out. And then there is one other thing we are going to do. We are going to install SQL Server Management Studio. So this is actually the client interface that you will use to connect to SQL Server itself. So what we have installed is we've installed the back-end service that will be maintaining your database, but in order to access the database, we'll need to install SQL Server Management Studio as the front-end application that you'll be using. So what you will be doing is you will click this Install SSMS. What it will actually do is it will open up another web page in your browser where you can download the installation file. So I've already done this. So this is the installation file that you will be using. So let me just double click this. And it will take a while to open. And again, it will ask you, are you sure you want to make changes to your device? Click on yes. So welcome, click install to begin. By clicking install, that you acknowledge that you are accepting the license terms and agreements and the privacy statement. And it will ask you for a location where you will install it. You can use the default or you can set up one of your own. I recommend using the default. So let's go ahead and start the installation. So click install. It is loading packages. And again, we will wait. So once again, we will spend quite a bit of time waiting for the installation. It's running. So you'll notice that it is actually downloading and installing a number of different packages that go into the front-end application itself. So once again, what I'm going to do is I'm going to pause this screencast while we are waiting on the installation to complete. And when we get close to completion, I will resume this broadcast. So just hang tight and we will be back in a little bit. Okay, and we are back. So SQL Server Management Studio has completed its setup. You will notice on the screen that there is a notification that a restart is required in order to complete the setup. So you need to restart the computer before setup can continue. So we will go ahead and click restart. And once you do that, you should be able to finish it up and launch SQL Server from your computer. So this has been the lesson. I hope that you have found this useful. And once you follow this process, you will be able to have SQL Server installed on your own computer where you can continue practicing these lessons. Thanks, and I look forward to talking with you on our next lesson. Welcome to this live stream demonstration. In this demonstration, we will be installing the AdventureWorks database from Microsoft. So AdventureWorks is a fictional company that Microsoft invented, and they've created a database based off of this fictional company that you can use to practice working on your SQL Server development, practicing your coding, writing your queries, inserting data into tables, and so forth. So let's go ahead and get started. So the first thing I want to do is we will open up your web browser, in this case Microsoft Edge, and all I'm going to do is I'm just going to search for the AdventureWorks database. So this will give you a list. So what you want to look for is this top setting right here, install and configure AdventureWorks sample database. So let's click on this. And this will bring you to a page where you can download the AdventureWorks database. So let's kind of go through the prerequisites. So in the prerequisites, we need to have SQL Server. So if you've followed the previous live stream demonstration where we installed SQL Server, you should have this on your machine. And also you should have SQL Server Management Studio. So the easiest thing we're going to do is we are actually going to download these BAK files. So BAK stands for backup. It is a database backup file. So easiest thing to do is just to download this from the Microsoft site. You do have the option also of downloading files from Microsoft's GitHub page, but we're going to download these from the sites. Now, I've already gone through the process. Of doing so. So we already have our databases. I've downloaded them to temp. So the next thing we're going to do is we are going to open up SQL Server Management Studio. So we'll just give it a moment while the SQL Server Management Studio warms up, which we installed in the last lesson. Okay, so when you open up SQL Server Management Studio, the first thing it's going to ask you to do is it's going to ask you to connect to a server. So if you have SQL Server installed on your local computers, all you have to do is just type in your computer name, or you can do what I have done here and just simply type in localhost. So I'm going to use localhost. So we're going to connect to that. And over on the right, you'll see the Object Explorer. So this opens up the server, the database server for localhost. So we have folders for various server level objects. So you have databases, you have security, some server objects. So let's go ahead and open up the database folder. So you can see there's nothing there. We opened up our system databases. So these are our 4 system databases: master, model, MSDB, and tempdb. So now what we are going to do is restore the AdventureWorks databases from the backups which we downloaded from Microsoft's site. So what we're going to do is we're going to right-click on databases, and this will open up a context menu. So we'll right-click and click on Restore Database. And it will prompt us for a database to restore. So what we need to do is we're going to click Device. Data backup files are called devices. It's kind of an old term that kind of comes from early database days. So this will give us a backup device. So we're looking for a file, and we're going to click Add. And I am going to type in my file location Okay, so the first thing we will do is we will restore the AdventureWorks 2017 backup. So click OK. That will bring this up here, so we'll click OK again. So it will give us a full rundown of the backup that we have. So a lot of these come from the Microsoft backup that they took. So let's go to Files. So I am going to, the first thing I'm going to do, I am going to relocate the file. So in our default, it has all the database files going to the program file. So I actually want to change this. So I have set up a file. I have set up a separate folder for data, and I have also set up a folder for my transaction log files. So let me find that here. Here it is. Okay, and then you notice that the file name has changed. So this is the original file name, and this is the restore as. So this, we're just verifying where our data files for our database are going to go. So this AdventureWorks 2017.mdf is our data file. So this will go in the data folder that I have selected. Meanwhile, the AdventureWorks 2017_log.ldf is our transaction log file, and that will go to the C log folder. And let's kind of click on options. So here are a few extra options that you can choose. If you already have an existing database, you can overwrite the existing database with replace. If you have replication, which we will discuss later, you can preserve the replication settings. And finally, you can restrict access to the restored server, to the restored database, which you might need to do if the database is not yet ready. There is a recovery state, so we'll just leave this as restore with recovery. So depending on the type of restore method you use, you may need to change this to something else. So all our settings are correct the way we do. So so what you can do at this point, you can click OK, but I am actually going to click this button up here that says script. So script will actually take all these settings from the window that I just made, and it will actually copy this to, you can either copy this to your clipboard, you can copy this to a SQL script file, or you can open a new query in the query editor window. So that is what I am going to do. And then I will hit cancel because I've already got my script. So let's look through the script here. So what we are doing is we are restoring our database, AdventureWorks, from disk. And what I'm doing is I'm going to do some indentation. It's always good to indent your code, because what you can do is when you experiment or when you're testing, by putting each line of code on a separate line, what you can actually do is you can uncomment out certain lines. So for example, here is this button says to comment out the selected line. So my cursor is on this line. So if I hit that, I press this, it will comment this out. And then I can always uncomment it by pressing the button right next to it to uncomment the second line. The other option is I can press Control, and then while I'm holding my Control down, press K, and then press C, and that will comment it out. And likewise, to uncomment it, you can, again, press Control, hold down your Control button, press K, and then press U, and that will uncomment everything. So this is the script to restore the AdventureWorks 2017 database. Now, one thing you may have noticed is I actually downloaded two. So there's AdventureWorks 2017, and then there's AdventureWorks DW 2017. So DW stands for the data warehouse. So data warehouse is a special type of database that is configured for business intelligence. So I am also going to restore this as well. So again, what I'm going to do is I'm going to right-click, restore database, click on device, click on this button, it's the little 3 dots or ellipses, add to my backup media, and then C backup file location, C /, temp. And AdventureWorks DW. Okay. Hit OK. Files, relocate all files. Again, C data. And C log. Then check on my options. These are good. And again, we'll hit script. This time, I actually want to copy this to the same script that I used to restore my other AdventureWorks database. So I'm actually going to copy this to the clipboard. Hit cancel. And from here, I will add an extra line space, edit, and paste. And again, I'm going to do a little bit of formatting. Formatting is good because clean code just works better. And now that I have my scripts, I will go ahead and execute. And as this runs, I'm going to click on, so when you click on queries, so it brings up two tabs, results and messages. So I'm going to go to messages so we can see, okay, so it's processed the first database, is now processing the second, so our query has executed successfully. So to verify, I'm just going to right click on databases and I'm going to click refresh. So this will refresh the metadata. So you can see, okay, I've got my AdventureWorks 2017 and AdventureWorks DW 2017. And let's go to the file server for a moment. So let us go look up our data folder. So you can see that there is an AdventureWorks MDF and an AdventureWorks DW MDF. And then on our log, AdventureWorks 2017 log LDF and AdventureWorks DW 2017 log LDF. So as you can see, this is a very simple and straightforward operation. So thank you very much for following along, and I will see you in the next lesson. The select query is the foundational command of SQL. This is the command that you use to return data from the database. In this lesson, we will cover all the components of the select query, as well as the best practices to writing effective and efficient queries. Select consists of a few main sections, which I will call clauses. The first part of select is the column list, which lists in order the columns and expressions to be returned by the query. The next part is the from clause, which specifies the tables where your columns come from, as well as the join conditions between tables. After from comes the where clause, which tells SQL which rows to return in the query. After that comes order by, which sorts the data in order by the columns listed, starting with the first one in ascending or descending order, then by the next, and so on and so forth. Finally, at the end comes the semicolon, which serves as the statement terminator. The semicolon is not required in all SQL commands, but it is required in some. As a best practice, always end your commands with a semicolon. You may have noticed in my example the use command at the beginning of the script. Although not a part of select itself, use is an important command. The use command tells the query window which database to run the script in. This is known as providing context for the query. Use is only required when running a query from a query program, such as SQL Server Management Studio or Visual Studio. It is not required when running a query programmatically, like through an application. Query context is important because it tells SQL Server which database to run the query from. Depending on the user's permissions, a user may not have permission to execute a query. It's also very important when joining or referencing tables in other databases. You can generally use any character, including spaces, in an object name. When I say objects, I include both tables and columns, but this also describes a lot of things we will cover in later lessons. To prevent SQL from confusing object names with command syntax, however, you use object name delimiters to identify objects. Square brackets are used to identify names for database objects, such as tables and columns. You can also use double quotes instead. Object name delimiters are not required if the object name consists only of letters, numbers, and a few select characters. The underscore character, $, and the pound or hashtag symbol. Also, make sure that your object name does not lead with a number. However, there's one important exception. If your object name also happens to be a reserved SQL keyword, you must use object name delimiters. So let's say I have a table that I have named as order, which is one of the reserved SQL keywords. If I was to write a query on this order table, I must use the square brackets as my object name delimiters. Otherwise, this is going to throw an error. As a general best practice, name your objects in a way where you don't need to use name delimiters. So if I have a column with a space, I have to use square brackets as my object name delimiters. However, I can eliminate the space and make this all one word. So because this is a compound name where I'm using multiple words in my column name, I have several options to identify the different words in my name. So the first one is Pascal casing, which is where I capitalize the first letter of every word. Another option is underscore casing, where I use the underscore character in place of a space. And finally, the last option is camel casing, which is similar to Pascal casing, except that you do not capitalize the first letter of the first word in my object name, in my column name. Whatever you do, be consistent in using the same naming convention throughout your code. SQL in general is case insensitive. This means that it treats both lowercase and uppercase characters as the same. However, you should follow the casing of the names in the database for good coding. An expression is a computed result that is returned as one of the columns in a select query. Here's an example of an expression. In this query, I'm multiplying the order amount column times tax rate to produce a result called sales tax. The as sales tax phrase at the end of my expression is a column alias. This means when the query returns results, it will label the column as sales tax. If you don't specify a column alias, SQL Server will still return the column, but it will have no name. This can sometimes be a problem if you end up using the query as a stand-in for another table. I recommend that you use column aliases every time you build an expression. You can use constant values in your SQL queries, like a number or a character string. Constant values are sometimes known as hard-coded values to distinguish them from things that could have variable values, like columns. When expressing character strings as constants, enclose the string in single quotes. In an expression, you can use operators to evaluate two values and return one based on its operation. Let's start with the basics. So there are the four mathematical operators: addition, subtraction, multiplication, and division. You can also use addition to join two character strings together. So this is called concatenation, when you join two strings together to make one string. And you can use the plus symbol to add those two strings together to concatenate them. Also, you can use parentheses to evaluate results inside the parentheses first before resolving anything else. There are also a few special operators, modulo and the bitwise operators. Modulo is related to division. It returns the remainder from whole number division. So, for example, let's say I had an expression of 5% 3, or 5 modulo 3. 5 divided by 3 in whole number division is 1 with a remainder of 2. So in my expression, 5 modulo 3 actually returns 2. The bitwise operators are a little bit special. So what they do is they break data down into its base binary components and then evaluate the binary components against each other. So in my expression here, I have two numbers. I have 5 and 3. So in binary, 5 is a combination of 1 plus 4. 4 being 2 to the power of 2. So that is my third bit expression. So reading the binary from right to left. So my far right is my 1 value. Second from the right is 2, which is 2 to the power of 1. Third is 4, which is 2 to the power of 2, and so on. So that's reading from right to left. That's 1, 2, 4, 8, 16, 32, 64, and 128. So these I have 8 binary places, so that makes a byte. So 5 is 4, which is my 2 to the power of 2 plus 1. And then 3, which is 2 plus 1. So my bitwise AND operator performs an AND operation against my binary digits. So 5 bitwise AND 3 actually returns a result of 1. The pipe operator, the vertical pipe, is a bitwise OR. So when it compares my binary positions, it will evaluate it will evaluate 1 whenever 1 appears in either binary position. So this actually produces a result of 7. And then my hat character, or my caret character, is a bitwise exclusive OR. So it will return 1 if the appropriate binary place is 1 and 0. However, if they are both 0 or both 1, it will actually return as 0. So 5 hat 3, 5 XOR 3, actually returns a 0 for my 1 position because 1 appears in both places. So this evaluates as 0. And then my 2 place evaluates as 1 because it's 1 in my 3 and it's 0 in my 5. And similarly, my 4 position evaluates as true because it is 4, it is 1 in my 5 value and 0 in my 3 value. So my XOR value is 6. With expressions, there is a specific order of operations. First, you evaluate the results inside the parentheses. Then, you resolve multiplication, division, and modulo operators from left to right. Then, you evaluate addition and subtraction from left to right. Then, I evaluate my bitwise AND operators from left to right. Then, my bitwise exclusive OR from left to right, and finally my bitwise OR from left to right. So here are a couple of examples. So in my first example, I have 50 minus 3 times 10 plus 6. So to follow the order of operations, multiplication comes before addition and subtraction. So I multiply 3 times 10 first. So that gives me 50 minus 30 plus 6. So I evaluate in that order. 50 minus 30 is 20, plus 6 is 26. Now in my second example, I have used parentheses to enclose 50 minus 3. So that evaluates first. So that becomes 47 times 10, which is 470, plus 6, which is 476. I recommend that if you have a expression where you have a combination of different operators at different levels, always use parentheses to indicate which ones evaluate first. This will eliminate any confusion when reading an expression, so you don't miss an implied order of operations precedence priority. There are a few special gotchas when working with expressions. First, with some of the older date and time data types, you can actually use mathematical operations in order to calculate a new date and time data type. However, this is not recommended. So in the example below, I've given a select getDate plus 1. GetDate is actually a function which returns the current date and time. If I add plus 1 to this, I will actually return tomorrow's date with the current time, because so getDate gives the current date and then plus 1 advances it by 1 day. So this is actually would return tomorrow's date with the current time. Now this works because getDate uses the date-time data type. However, it won't work if you use an expression where you're using a newer data type like date-time offset, which also includes the time zone offset. You can't do an addition to a date-time offset data type. So the best thing to do is to avoid using mathematical operations with date-time data types. You may see this in some of your older code. I recommend that you don't follow that practice. Second thing you need to watch out for when you are working with numbers. Some numbers may be whole number only. These are called integers. If you divide integers by another integer, this actually results in whole number division. So it will give you a result that you would not normally expect. So example, 1 divided by 10. If these are both integers, this will produce a result of 0 rather than 0.1, which is what you would normally expect from 1 divided by 10. And similarly, 11 divided by 10. If these are both integer values, this will actually produce a result of 1. Now, this is not always a bad thing. Sometimes you do want to perform integer division, but make sure that you watch out for your numerical data types when performing division, because if you don't pay attention, you may get an unexpected result. A function is an object that returns a specific value based on the inputs or arguments passed into it. So in the previous slide, I showed you an example of a function, getDate, which returns the current date and time. So that is one example of a function. To use a function, type the function name followed by parentheses, listing the arguments in order as specified by the function definition, and then close your parentheses. You must always use parentheses when working with the function. If you saw before with getDate, I had a pair of parentheses, but there was nothing inside because getDate does not take an argument. However, I still have to type the parentheses when using getDate. Otherwise, it's going to throw an error. So here's an example of a function in use. Substring is a function that works on text strings, and it will return a portion of an input string based on the starting position and the length of my substring. So in this case, I have a substring function which evaluates my input string as green, eggs, and ham. My starting position is 7, so that would be the 7th character from the left. So that would be E in eggs. And then 4 is the length of my string. So this will actually return eggs from my input string of green eggs and ham. Null is a special type of value. Null indicates the lack of any kind of value. It's not the same as having either a zero numerical value or an empty string or binary value. In many cases, null means that a value is either unknown or not applicable. When combining null with a value in an operation, the result is always null. So in my example, if I have 1 plus null, this will result in null. There are a few special functions that are designed to work with null. The first is isNull. So in the isNull function, if the value of the first argument is null, it replaces it with the value of the second argument. Coalesce is similar to isNull, but you can specify multiple arguments. So if the first argument is not null, it returns the first argument. If it is null, it returns the second argument if that is also not null. However, if both of them are null, then it will return the third argument, and so on and so forth. Coalesce will only return a null if all the arguments passed in are null. Finally, there is the nullIf function. NullIf is actually the opposite of isNull. So in a nullIf, it replaces the results of the first argument with null if it matches the value in my second argument, my replacement value. Case is a special type of expression. You specify a certain condition to be true, and if it is true, it returns a result. If it is not true, it moves on to the next condition to evaluate and returns a result, and so on until it exhausts all the cases. So in my example below, I have a case expression where I'm evaluating a column called color code. So in my first expression, when the color code is pound FF0000, then it returns a string value of red. If that is not true, then it moves on to my next condition. When color code is pound 00FF00, then it returns green. If that's also not true, then it moves to the next condition, and so on and so forth. If it gets to the end, if all conditions specified are not true, then it will default to the results specified in my else. In this case, it would be other. And finally, in my case statement, I terminate it with an end keyword. So to use a case expression, you open with the case keyword. You list each condition using when followed by the condition, and then use the then keyword followed by the result to give if that's true. You list these in order, and they will be evaluated in the order that's specified. If you exhaust all your when conditions, you can use else to specify default condition. If all conditions are false, however, and there is no else default, case will return null as the value. Finally, remember when you have a case expression to always terminate your case expression with the end keyword. Select star is shorthand for returning all available rows from a table. If you have multiple tables in a query, you can use the table name before star to return all the rows in that particular table. So in this example, I have a query where I am joining a table named President to another table named American State. So in my query, I've typed p.star. So p is a table alias that references my President's table. So what I am saying is return all the columns from the President's table. And then st is a table alias for American State, and I'm saying return only the state name column from that table.
Order by sorts the results of a query. Specify a list of columns or expressions to sort the results. It will sort in order of the first column specified, then the second, and so on. Columns and expressions can be sorted in ascending or descending order. If you don't specify an order, order by will default to ascending order. The columns and expressions used in order by don't have to appear in the select column list. If you look at the example down below, I am running a select query from a song table where I'm returning the song name and the song artist. However, you'll notice in my order by, I have a replace function where I am replacing the word the with an empty space. So that way it's like if the artist's name begins with a the, then it won't actually put all the these in the T section. You can limit the number of rows returned in the query by specifying top after the select keyword. Select top limits the number of rows returned in a query either by a set number or a percentage of the total set. So if you look down below my two examples, I've got on the left I've got a select top 1000, which will return the first 1000 rows, and then the next one it will return a select top 10%. And this is going to be a rough approximation to 10% of the result set. It's a good idea to include an order by clause in a select topped query. This allows you to control which rows are being returned by the query. Only the first specified rows are returned, so order by will sort the rows before select top establishes the cutoff. Finally, let's look at a special case called select distinct. Select distinct condenses the results of a query by eliminating duplicate rows with the exact same combination of values. So if you specify select distinct and then the rest of your query, this will actually return unique results. So what will happen is that you won't have two rows that have the exact same contents in the query results. One word of caution when working with select distinct. This requires more processing than an ordinary select. Only use it when you know for sure there are duplicate values that you want to eliminate. When using order by with select distinct, you can only sort columns that appear in the column list. Here's some best practices when it comes to writing select queries. First, put each column in your column list on a separate line. So you can see in my example below, I've got 3 columns, but I am putting each column on a separate line. The reason for this is that it makes it easier to test and debug your queries, which is inevitably going to be happening, especially as like if you are writing a query in support of an application. Second, use column aliases for all expressions. This will save you a lot of trouble, especially as like if you are using that query as a source for another query. If you have 2 or more columns that have the same name, make sure that you use column aliases to create unique names. This avoids a potential ambiguity or duplication violation in your result sets that can avoid some errors. And finally, avoid using the select star shorthand in scripted code. In the next lesson, we'll cover the from clause. This governs the tables that you pull from and the relationships between the tables used to combine rows from one table to those of another. I'll see you in the next lesson. The previous lesson provided an overview of the select query. In this lesson, we'll cover the from clause of the select query, which tells the database which tables to retrieve data. Let's dive right in.
From identifies the tables you will be using to retrieve data in your query. It also defines a relationship between tables when querying multiple tables at once. When referencing tables in from, you can use an alias as a stand-in for the table name. This is particularly helpful if you have a long table name or are joining tables from a different database where you have to use a multi-part name. A table name consists of 3 parts: the database name, the schema name, and the table name. The database name identifies which database holds the table. Schema is a subcontainer which groups similar objects together. It helps in managing database security, and it also makes it easy to identify which tables are more closely related. If you're familiar with object-oriented programming, You can think of a schema as something similar to a namespace. If a query is run in the same database where the table resides, you can actually omit the database name. The schema name and the table name are still required, however. When you have a combination of schema and object name, or schema and table name in this case, this is known as a two-part name. In some cases, you can even omit the schema name and refer to the table by its name alone. If the schema is considered the user's default schema, or the schema is DBO, you can omit the schema name. As a general best practice, create users with the default schema as DBO. This requires users to always use a two-part name whenever referencing objects in schemas other than DBO. Here are a couple of best practices when referring to tables. First, make sure that you use the two-part name even if you are allowed to use the table name alone. So in my example, I have a table 1 in my DBO schema. It's good practice to type out that DBO even though you don't need to. The reason being is one-part names can actually cause problems with SQL Server sometimes. Again, because of the issue with default schemas. Different users can have different default schemas. So if you use a one-part name, this can actually cause an error if a different user with a different default schema is running that query. So the best thing to do is to always use a two-part name, even if you don't have to. Also, make sure to use table aliases unless there's only one table in the query. Use short table aliases, ideally 3 characters or less. The whole point of a table alias is to shorten the table reference when referring to a table in either your select list or your joins, because when you are joining columns together, you will need to reference the column, which table the columns come from. Lastly, always prefix your column names with a table name or alias, even if the name is unique to one table in the query. Joins allow you to return data from 2 or more tables together in a single query. Joins are the most powerful part of a relational database. A join consists of 2 parts, the table being joined and the join conditions, key fields on both tables that match a row on one table to one or more rows on the other. An inner join joins 2 tables on matching values. Whenever the key columns in both tables meet the criteria specified, then the query returns rows with columns from both. Here's an example showing the use of inner join. In the table on the left, we have a partial list of American presidents. In the table on the right, we have a partial list of American states. We join our 2 tables by state using the home state column in our presidents table with our state code in the states table. As you can see, there are only 3 rows in presidents that join to 2 rows in states. Our inner join therefore returns 3 rows. You'll notice the columns from the state table that the row for Massachusetts is duplicated twice because it matches 2 of the presidents from my presidents table. An outer join joins 2 tables on matching values. It will return all the values from one table, the inner table, as well as values from the other table, the outer table, where the rows meet the join criteria. If a row on the inner table doesn't match with the row on the outer table, the null will be returned in place of an actual value in my outer table columns. There are 3 types of outer joins: left, right, and full. So in my example query above, I've got a space where I can specify where my outer joins. In my left join, I will return all the rows from table 1 and matching rows from table 2. In my right join, I return all the rows from table 2 and match with rows from table 1. Finally, in my full join, I return all rows from both tables. So here is an example. Let's look at our example again with presidents and states. In my left outer join, I'm returning all my presidents. So in my state columns, because I am matching 3, only 3 of those rows are going to be populated. For the ones where they don't match, I still bring them back, but I put null as my column values. In my right join, it works the other way. Now I'm bringing back all my state tables, and in my present columns, I'm returning values only where the join matches on both tables. And finally, in my full outer join, you can see I'm bringing back all my rows from both tables. So I am listing all my presidents and I'm listing all my states. And where they are joined, I am combining the two values together on the same row. You can see at the bottom with the ellipsis, this is going to be a huge table because I'm bringing back all my presidents and all my states. So I'm kind of truncated my example in this case. Novice developers often make a common mistake when using queries combining both inner and outer joins. Inner join limits the results of 2 tables to results that match both tables. When using inner join and outer join in the same query, make sure your inner join connects to the inner table, the one returning all rows. If you perform an inner join against the outer table, which returns only those rows that match, it will effectively turn the outer join into another inner join. A cross join maps every row of one table to every row of another. This occurs if there is no joining relationship between the 2 tables. Cross joins can result in very large sets because the number of rows in the first table is multiplied by the number of rows in the second table. This is sometimes called a Cartesian product. Be careful when using a cross join that you find ways to limit the query results with where clause conditions. So here's an example of a cross join. So I have one table which has a list of dates, September 1st, September 2nd, and September 3rd. And then in my second table, I have a list of times, 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m., and 6 a.m. When I perform a cross join on both tables, so you can see for September 1st, I have a row for every time. So I have September 1st, 1 a.m., September 1st, 2 a.m., September 1st, 3 a.m., and so on. And then September 2nd, 1 a.m., September 2nd, 2 a.m., September 2nd, 3 a.m. And of course, and finally September 3rd, 1 a.m., 2 a.m., 3 a.m., etc. So you can see how with a cross join, your result set can grow really big. You can join a table to itself using an inner, outer, or cross joins. When this occurs, it is considered a self-join. When performing a self-join, you must use table aliases. This identifies to SQL which column from which table is used in any given situation. So here's an example of a self-join. So I have a table of employees. So I've got an employee ID, the first name, the last name, and the manager ID. The manager ID identifies who the manager is for that particular employee. So for employee ID 1, Michael Scott, he is actually a manager and he has nobody above him, so his manager ID is null. However, for rows 2 through 5, these all have Michael Scott as their manager. So you can see that the manager ID in this case refers back to employee ID 1. If I wanted to write a query that brought back a list of all employees, their name, and then their manager's ID and name, what I would do is I would do a self join on my employee table back to itself. So I am joining employee EMP to employee MGR, and I am joining on emp.managerID to mgr.employeeID. So this is a self join, so it brings back all my employee names and then my manager names. You can see here how I am using the table alias as shorthand to reference which employee table is used in which particular column. If you are developing code for a long-lived application, sometimes you might see some older code which has a special type of formatting for their joins. It might read like from table A, comma, table B, where table A.rowID equals table B.rowID. This is known as a comma join. Sometimes you may hear it referenced as an equijoin. Comma joins are a much older form of an inner join and works just like an inner join. However, it's not very efficient performance-wise. In SQL Server, this will eventually be phased out. If you see something like this, just realize that this is functionally equivalent to an inner join. Whenever possible, I recommend that you replace this with an inner join.
In the next lesson, we'll cover the where clause, which filters the results returned from the query. This limits your results only to the ones relevant to you. In this lesson, we'll cover the where clause, which filters the results returned from the query. This limits your results only to the ones relevant to you. Let's get started.
The where clause limits the results returned in the query. This filters the results in a table only to the ones which you want. In a where clause, you specify the conditions that must be true. If the row values meet those criteria, the row appears in your query. In a where clause, null doesn't evaluate as true or false, but simply as unknown. This means that rows in a where a condition evaluates as null, the row will not appear. If you want a query to return results where the results are null, use the phrase isNull instead. So if I wanted my X column, I want to bring back all the rows where the result in my X column is null, I would specify where X is null. Similarly, if you want the query to return all results that aren't null, regardless of value, then use the phrase isNotNull. Novice developers often make a common mistake when using a where condition with an outer join. If you combine two tables using an outer join, the outer table's row value will be null if the table's row doesn't meet the join condition. The where clause operates after join conditions have been applied, so you must take into consideration that rows in the outer table may be null due to mismatches. New developers often forget this. If you want to filter for certain conditions for certain results in the outer table, while still returning all the rows in the inner table, include the filter as part of the join condition. Here's an example that illustrates the mistake that many novice developers make. Let's say I'm writing a query that lists all my active customers and returns a count of the number of orders they've made in the month of May 2019. If I filter where the order date is between May 1st and May 31st, I will only get those customers that actually made an order in May. Because when I make an outer join between customers and orders, the order date is null whenever a customer has made no orders, and the where clause will filter out those null order dates. To get the correct result for my query, I might make my filter on order date part of the outer join condition between customers and orders. This way, if I have an active customer who has had no orders in May, they will still show up in my query. Where uses a different set of operators to compare values. These are called logical operators. So listed below are the common logical operators that are used: equal, greater than, less than, greater than or equal, less than or equal, and finally not equal. Not equal uses two different forms of syntax. So you have a greater than, less than symbol. You also have exclamation point equals, which is a version of not equals that is used in other programming language. Both expressions both mean not equal. There are a few other special logical operators. The first one is in. The in operator allows you to check for values that can match multiple values at once. So in my example, if I am searching for a first name of John, James, Roger, or Tom, I can use the in operator to specify my first name being any one of those four names. The next logical operator is between. Between filters for values in a range. It returns back rows where the condition is greater than or equal to the lower limit and less than or equal to the upper value. For example, where a number value is between 1 and 10, it will return back all the rows where that particular column, the number is 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Couple of items of caution when working with between. First, if the range values are in reverse order, the between operator will not return any values. Second, when working with datetime data types, be mindful of the time component of the upper range boundary. When you have a compound result, sometimes this can be misinterpreted as a date. So if you have a time, this will actually cause your between operator to miss some rows because the time is not the same as the date. So something to be careful of when working with date and time. The like operator performs pattern matching on character data types. It uses wildcard characters to define the patterns being matched. The first wildcard is the underscore character, which matches any single character in a character string. Next, if I wanted to match any single character to a range of values, I can use square brackets to list the values I want to filter for. In the square brackets, I can use the hyphen character as an abbreviation for a range. In this example, matching any alphabetical character from A to Z. If I use the caret or hat character immediately after the opening square bracket, I tell my like operator to match any single character that is not in that range of values. So to go back to my previous example, if I was to have square bracket hat A to Z, then I would match in that position any character that is not an alphabetical character. The percent character is a wildcard that matches 0 or more characters. This is a pretty powerful wildcard. If I put my percent at the end of the string, I will tell it to match any string that begins with the phrase listed. So like AA% matches any string that begins with AA. If I put my percent at the beginning, I'm telling like to match any string that ends with the pattern that I've specified. So in this case, like %AA says will match any string that ends in AA. Finally, if I bracket my strings with the percent symbols at each end, I will match any string that contains the pattern anywhere in the text. Finally, there is escape keyword. If I use escape, I must specify a single character as a designated escape character. This tells the like operator to ignore any wildcard that immediately follows my escape character. Boolean operators combine multiple logical operators together to return a single true or false values. There are three Boolean operators: and, or, and not. So and returns true if both conditions are true. So if you look at the and result matrix in the bottom left, if condition A is true and condition B is true, then it will return true. But if either one of them is false or they are both false, then it will return false. Or is the opposite. Or returns true if either one of the conditions is true. So On the bottom right is an OR result matrix. So if I have a condition A on my top, my header, and a condition B, which is my row, then A or B will return true if either one of them is true or they are both true. It will only return false if they are both false. Finally, there is the not operator. Not will return the opposite of the specified condition that comes after the not operator. With logical operators, there is also a specific order of operations. First, you evaluate the results inside your parentheses. Then you invert not conditions. Then you evaluate conditions joined by and finally you evaluate conditions joined by or. As a helpful pro tip, make sure you use parentheses whenever a where clause contains a mixture of ands and ors. This will avoid any confusion caused because of order of operations. This lesson has covered all the essential components of the select query. As I said before, select is a foundational command in the SQL language, so it's very important that you learn how to use it correctly. If there are any parts that you found unclear, make sure you go back and listen to it over again so that you understand how it's used. One thing to note is that select only reads back existing data. In order to read data, you have to write it to the database, and there are separate commands that do that: insert, update, delete, and merge. We will cover that in the next lesson, and I will see you then.